Last episode, we solved the problem of one conversation getting too long. But there's a bigger problem we only gestured at. What about across conversations? You tell an assistant on Monday that you are allergic to peanuts. On Friday, in a brand new chat, you ask it for a recipe. A summary of Monday's chat is long gone, the session ended. So how could it possibly remember the allergy? It needs memory that survives across sessions, and that can find one specific fact out of thousands without rereading them all. The standard way to build that is vector memory, and it is just two ideas you already know, embeddings and vector databases, pointed at the agent's own past. Quick note, before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Here's the whole idea in one sentence. Vector memory stores each fact or message as an embedding in a vector database, and later retrieves the few memories most relevant to the current moment by searching on meaning, so the agent can recall things across completely separate sessions. If that sounds like RAG, you are exactly right. This is the retrieval machinery from episode 13 onward, but instead of retrieving from a library of documents, the agent is retrieving from its own memory of you. Let me rebuild it from the pieces because you already own all of them. Back in episode 3, we learned that an embedding turns a piece of text into a list of numbers, a vector, that captures its meaning, so the texts with similar meaning end up close together in that number space. And in episode 15, we learned that a vector database stores millions of those vectors and, given a new one, instantly finds the closest matches. Vector memory simply puts those two together and aims them at memory. Every time something worth remembering happens, you embed it and save it. Every time the agent needs to remember, it embeds the current situation and searches for the nearest saved memories. That is the entire mechanism. So let me walk the two halves slowly, because the magic is in the loop. The first half is writing a memory. When you say, "I am allergic to peanuts," the agent takes that fact, runs it through an embedding model to get its vector, and stores the vector alongside the original text in the database. It is now a permanent note, sitting in long-term memory, with the session safely able to end. The second half is reading a memory. On Friday, when you ask for a recipe, the agent does not dump your entire history into the prompt. Instead, it embeds your current request, asks the vector database for the most similar stored memories, and back comes the peanut allergy, because in meaning space, asking for a recipe sits close to a note about food allergies. The agent drops that retrieve fact into the context window, and the model answers as if it remembered all along. Write on the way in, search on the way out. Now, why go to all this trouble instead of just keeping a long summary of everything like last episode? Two reasons, and they are the whole point. First, precision. A summary is lossy, as we said. It smooths away exact details. Vector memory stores facts verbatim, so the peanut allergy comes back word for word, not as a vague impression. Second, scale and relevance. You might accumulate thousands of memories over months, and you can never fit all of them in the context window, nor would you want to. As we learned in episode 2, every token costs money, and as we saw with long context, irrelevant clutter actually makes the model worse. Vector search fixes both at once. It pulls back only the handful of memories that actually match this moment, ignoring the thousands that do not. That selectivity, retrieving the relevant few and nothing else, is the superpower summarization simply does not have. It is worth being clear on how this differs from last episode because they are partners, not rivals. Summarization compresses the recent conversation so it keeps fitting in the window. It is about now, this chat, staying coherent. Vector memory stores discrete facts forever and fetches them on demand. It is about then, across all chats, recalling specifics. A serious assistant uses both. Summary memory to hold the thread of the current talk, and vector memory to remember who you are between talks. Together, they are short-term and long-term memory made real. So how does this land depending on who you are? As an individual, this is precisely the feature behind an assistant that feels like it knows you, that never makes you repeat your preferences. The convenience is huge, which is also why it is worth knowing exactly what it is quietly storing about you. As a startup, vector memory is usually how you ship a real memory feature. And the good news from earlier in the course is that you already have the parts. The same embedding model and vector database from your RAG stack now double as your memory store, so it is far less new work than it sounds. And as a large enterprise, the moment you embed and store what users tell you, you are persisting personal data in a searchable form, so per user isolation, so one customer's memories never surface for another. Plus consent and deletion become hard requirements, not nice to haves. So let us bring it home. To remember across sessions, an agent turns each fact into an embedding and stores it in a vector database, then later searches that store by meaning to pull back only the memories relevant to the current moment. The very same retrieval idea from RAG, aimed at the agent's own past instead of at documents. It gives you precise, verbatim recall at huge scale, the perfect complement to the lossy, in-the-moment compression of summarization. But now a new and harder question appears. If the agent can save memories forever, should it save everything? What is worth keeping? What should it quietly forget? And how does it stop its own memory from filling with junk? That is the art of memory management, and it is exactly where we go next. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments which you want broken down next. Thanks for watching.